My name is Anna, and first of all, I would like to thank these events organizers for the opportunity to share my experience here in the DevOps world. I have been an IT consultant for the last 10 years. I work for Noesis, which is a Portuguese IT consulting company with 25 years in the market and offices in 6 countries. It offers several services for its clients through its associated business units, one of them being the DevOps and automation area, to which I am associated to. The purpose of this presentation is to show you all what my team and I have been doing for one of our clients. So, this client is one of the largest companies here in Portugal. My team is responsible for the development and support of tools and processes that run the software lifecycle process. That is, things like source control management, build and packaging of artifacts, deployment management, and all the other things that you can see here. As you can imagine, a company of this size has hundreds of ongoing projects. Some of them follow the CI/CD process and others don't. To complicate things further, there were 2 CI/CD processes, one for the development environment and another for the testing environment. The CI/CD process on the development environment was limited to build and deployment tasks and only for a small group of projects. For the testing environment, we actually didn't have continuous integration. What we had was a 2-hour window every day to run our pipelines that built and deployed the projects. If something went wrong and the developers had to correct something, the code could only be delivered on the next window. It was obvious to everyone that things couldn't go on like this, so the owners of both processes agreed to unify things into a single system. This was also an opportunity to standardize projects integration and increase its capabilities. So, to achieve this, we identified 5 main challenges. First challenge, we had a legacy infrastructure to run our CI/CD process. This infrastructure, based on VMs, didn't have enough resources for our growing needs, had limited network bandwidth, and we had no access control over it. To give you a real-life example, one of our Java portals would take 70 minutes to compile and 15 minutes to deploy. The second and third challenges were dependent on the first one. The market offered several options to expand our pipelines with new features, but we didn't have the ability to test or implement them with the available infrastructure. The fourth challenge was shifting left. That is, to perform tasks exclusively in the development phase that were previously done in later phases of the software lifecycle. For example, we wanted to stop building the same code in development and again in the testing phase of the pipeline. Therefore, by shifting left, we could anticipate problems and the developers could increase the quality of the code delivered. The last challenge, and possibly the most gratifying to overcome, was to empower other teams in true DevOps spirit. A new infrastructure would solve many of the challenges that I just talked about. However, we wanted to take things one step further and take advantage of everything that containers could provide us. In our case, high availability, an always clean and controlled environment, and scalability. We quickly settled on Docker as our container technology of choice, as it was the most widely used technology in the industry. We then proceeded to evaluate the various Docker management solutions available. Swarm was the first solution to be discarded, which left OpenShift and Kubernetes as the remaining contenders. In the end, we opted for Kubernetes because, in our opinion, it offered greater customization and was easier and quicker to adapt to our needs. In this drawing, you can see the architecture we ended up with. You can see a pod that only runs the Jenkins container. The pipeline's code is run in the other nodes. So each pipeline runs in a single node and each stage is run on its unique container. The number of containers launched by a pod depends on the type of pipeline being run. The cluster is running on our client's data center and is administered by our team. Those familiar with Jenkins probably recognize the widget here on the left. It displays the jobs running on all the Jenkins nodes. In our case, we don't have any dedicated nodes or slaves. Instead, only the active containers in our clusters, in our Kubernetes cluster show up. On the right, you can see the Groovy code for provisioning the pod in the pipeline. In this example, you can see the pod is launched with 4 containers that will be used in the pipeline at different stages. Here we have the stack, starting from the bottom, which shows CentOS for our Containers OS because it's free. And we had Experience running Red Hat and its derivatives. The middle level displays all the technologies used by the Kubernetes infrastructure. And at the top, we have all the applications that are run in the containers used by the pipelines. All Docker images created by us and others are stored here in Artifactory. This is a high-level description of the pipeline workflow. We have Jenkins here at the center as the orchestrator. And the trigger to start the pipeline is a pull request in GitLab. Then the pipeline proceeds to static code analysis that can be performed by any of these tools. In parallel, we have a build task which can run any of these builders. After a successful build, the artifacts are published to Artifactory. In case of a deployment task, it can be done through SSH to a virtual machine or through an OpenShift client to an OpenShift server. Finally, the testing phase can be performed with any of these tools. All these phases, from 1 to 5, are run using containers. This screenshot shows our first release of the pipeline. We start with a pipeline configuration stage, where we do tasks like instantiating the pods, checking out the pipeline code and products, and configuring the pipeline environment. This is followed by static code analysis, and then the parameterized stage that prepares the configuration files for deployment. In the build stage, we compile our various projects. It could be Java, Python, or ProC. We then publish the artifacts to Artifactory and request user input for the deployment. Finally, we have the automated deployment and regression testing. All the stages execution on the pipeline are controlled by the developers. It means that the teams can decide if they wish to run them or not. Here is an example of a configuration file template for a pipeline instantiated by development. On the left side, we have the folder structure in the repository with the control files for the pipeline. Some are maintained by my team, and the others are the development team's responsibility. In the middle, we have the pipeline configuration file. In this case, development specified that it is a Gradle project, its build tasks, and what artifacts are to be delivered. We also have the files with the deployment instructions on the desired environments. On the right side, we have the deployment flow together with preparatory and post-deployment tasks. Now the good. With our first pipeline release, we achieved high availability because if an environment is unavailable, a new one can easily be created. This ease of creation also allows any environment to scale up or down. It is easy to assign a container on demand, code sharing between different pipelines. The pod with all the containers is created at the beginning of the pipeline execution and takes less than 15 seconds to be available. It is simple to maintain, modular, and easy to reuse. The drawbacks, the initial ramp up took a bit longer than expected because there was no previous knowledge on container technologies in the team. And we still had problems with our infrastructure because the NFS used by the Kubernetes cluster was also shared with other projects. So at certain times, the I/O performance available to us was extremely limited. It got to a point where we have had failed builds because of the severe slowdown. And the very bad, this NFS-based solution also led to a node behavior where we had data corruption due to an overlap of files from different parallel builds. This was due to the way we performed the checkouts from the GitLab, along with the process followed in-house to implement the pipelines. To further add to our headaches, the network administrators decided to change their policies without notifying us. So, overnight, our entire production solution stopped working and we had to shift everything to the much slower development infrastructure to keep things going. At this point, we decided the best solution is to start to work on a new architecture, and so we did. And that brings us to a new version of the pipeline, and this is how it looks now. Along with the issues mentioned earlier, there were additional requirements that led us to the improvements that I'm going to present you in the next slides. In this stage, pipeline configuration, we provisioned the pods as we did before, but with a big difference. Now, we no longer mount the container attached to the NFS. Instead, we do the checkout directly on the container's memory. That also brought us an unplanned improvement with the checkout times. In the build stage, that change not only brought faster execution times, but also solved the problems related with parallel builds. The client adds an additional requirement for the pipeline in the development environment. Deployments should only be done if explicitly requested. This is to prevent any sudden unavailability or change of behavior in an integrated environment that could be underused by other teams. This led us into splitting the build and deployment pipelines, where the later one is only run if the developer asks for it. This is how the deploy pipeline looks like. It has a configuration stage like the build one, then the deploy itself, followed by an API and GUI testing. Both pipelines, build and deploy, log their results in the logging deployment stage. These logs are then consumed and shown on ELK. Good things from this new version. The performance issues that plagued us in the first iteration are mostly gone. All stakeholders now trust the CI/CD platform to deliver the required results. We have even had developers that heard about our platform from their colleagues, asking us to integrate their projects into the pipeline. And with the addition of ELK to the pipeline, we can now measure and improve the performance of our solution. The things to be improved, we still have the occasional network issue, but it's not just as bad as it was before. And the development and testing pipelines still haven't been completely merged. This is because the deployment for testing and production is still controlled by a legacy release management process/tool. Here, we can see the improvement in build times between the two pipeline release versions. These graphs correspond to the first 3 projects that we migrated to our pipeline. You can see an overall decrease in build times for all of them. Remember the Java portal I mentioned in the beginning, the one that took 17 minutes to compile? It's this project A. Its build time was initially decreased to 7 minutes on pipeline release 1, and then 1.5 minutes on release 2. And these are just some stats from the last year for the 20 projects already onboarded. We already had more than 7,000 pipeline runs, resulting in more than 1,000 automated deployments. Many more will come. So, next steps. For our next steps, we have the following planned actions. There is currently a project to implement a new release management process, transversal to all environments that will integrate with our pipeline. We also plan to migrate database deployments from the release management tool to the pipelines, have all the tools in our CI/CD stack in containers, such as GitLab and Artifactory, and extend the pipelines all the way to the production environment. And that's all. Thank you for your time, and I hope you have enjoyed this presentation about my experience, and I'm looking forward to your questions.
Thank you so much, Anna. That was great. So we have time now for Q&A. There was already one question that I saw in the chat from Mona. You were asking, they were asking if you could clarify what was the development methodology, agile or waterfall.
Pardon?
The question is if you could clarify what was the development methodology, if it was agile or waterfall.
In which processes?
That's a good question. This was more or less halfway through your talk. I don't know if Mona wants.
Sorry, Manuel. We had the main development process is agile for both processes.
Okay. I think that answers the question. So there is another question, a few more questions, so I'll read them out to you. So we have Nuno Justo joining us from Zurich. That's cool. So the question is regarding artifacts. Are they also images in the registry? Because I don't see security measures for images in the process.
We have, we have images stored on the Artifactory registry. Mainly the images mainly used in our pipeline are controlled by us. We decide which versions of the software are installed in each image. We are also working on a solution to validate the security of those images before they are deployed to the production environment. We try to control that security by having the images under our control. I don't know if that answers the questions that it was done.
I think so. I think that answers the question. In any case, I've now changed the settings so people can unmute themselves if you want to ask a question. Otherwise, I'll just continue with the questions in the chat. So Patrice Corbard is in Ericeira. and is asking, could you tell us more about the business context and business goals targeted for this DevOps initiative?
It is more like giving the, first of all, we had those two processes. We had a scenario where we built, the binaries that were deployed in the development environment weren't exactly the binaries deployed in the tests and production environment, because the code was again built before entering the testing environment. We also wanted to give the teams more autonomy. We wanted to end with that situation where the teams are limited by the 2-hour window for the deployment in the testing environment. Because it was frustrating. If the build failed for some reason, they had to wait until the next window of the next available deployment frame. The goal itself was to try to make things more agile at the end, give teams more autonomy, more empowerment. Those are the main goals for this initiative.
So next question from Pedro G. He says, "Hi Ana, thanks for sharing your insights over Kubernetes and Jenkins. If I have not missed anything you said, have you considered Jenkins X instead of Jenkins?"
Good question. Yes, you haven't missed, but we actually at the beginning considered Jenkins X. We even did some studied for a while the possibility, but when we started the project, Jenkins X was still at the beginning. It wasn't quite mature enough for what we wanted, so we didn't evolve on that way. That's why it wasn't considered for our solution. We didn't consider it was mature enough.
Okay, and the next question from J. Pereira. Is it possible to explain again why was Docker Swarm discarded at first? Thank you.
Okay. Docker Swarm because it didn't respond to all our needs. We needed a more complete solution, and we saw that Swarm wasn't enough. We wanted a little more customization. So that's why we ended up in Kubernetes, because we think it's, although it can be more difficult to install, for example, in the end it's more customizable. And it was what we wanted at the time, to have a more customizable solution.
Thank you. Hi, Ana. So on my previous company, we had a similar approach. And one of the hardest things that we had was to balance the self-service with the capability of innovation from the team. And from what I saw, you have about 3 or 4 images that you make available, and teams can use those containers to execute commands. But sometimes the teams to innovate needs a new version of a container or a new version of, I don't know, PHP, C#, whatever. How do you balance that and keep the things secure and scalable? Thanks.
Good question, Sergio. Thank you. Actually, yes, we, at the beginning, just to contextualize, we started with only Gradle and Maven. And with the evolution of the pipeline, we had to introduce new builders, like you mentioned. So our option is to, we have each project has a configuration file where we associate which builder is to be used for that project. What we have actually is the pod with the 4 containers, but the builder, for example, is highly configurable. We read in runtime that configuration file with the information of the Docker file that is to be loaded, and that image is loaded with the pod. When we say we load a pod with 4 containers, those containers those pods are not the same for all the projects. We have the 4, but the builder is highly customizable. It's according to the project context.
Thank you, Ana. So we have another question here from Alcindo Ramalho. Hello, thanks for the presentation, very clear. You mentioned that there were several projects with different stages or approaches to CI. Besides the integration with the pipeline, were any standardization needed from the teams in their development process? For example, branch management flows, or can it deal with several, I guess, approaches to flow?
Hello, thank you for the question. Besides integration and the pipeline. Yes, actually, actually what we wanted was that the teams followed the same process. What do you mean with several flow approach? Besides integration?
Alcindo is saying, for example, Git flow.
Git flow. Trunk based. The company has its development process. Every team, everyone, everyone in the pipeline has to follow the same flow. They have certain rules where the trunk branch represents the production code, and the teams it's a standard common Git flow. But that is not defined by our process. It's a process defined by the owners of the development process. We just support the software lifecycle. Did I answer the question? I don't know if I was clear. Okay.
Alcindo says yes, you have answered this question. So we have a couple more, and maybe we'll wrap up after that. So Ricardo Santos, he's in Romania, so it's pretty far as well. So greetings, can you give an overview how you manage pipelines for multiple branches? Do you have multi-branch pipelines?
Yes, we have. It's well, every branch has that configuration file that I showed in the presentation. They just need to commit on the GitLab, and then the Jenkins manage the branch. It compiles the code associated to the branch, and then it's all Jenkins management. But yes, we support multi-branch pipelines.
Okay, so I guess we'll go to the last question from Pedro G. If it is possible to share, how long did you take to reach this configuration up and running?
Which one? The first version or the second version?
I guess maybe can answer for both, I guess.
Okay, the first version took us about 3 months. The second version was, it was as long as we changed the way we did the checkout. It was quick. I don't remember exactly how much did we take, but it was very quick because we had a pipeline already ongoing. We just had to change the way after we had to rebuild our cluster. It was just to change the way the checkout was done.
I think we've covered all the questions.
Thank you all for the questions.